Unajua?
Naweza pause kwanza.
Waje nipike story na wao. Thank you for joining. If you are in, you can talk to me. We are starting as soon as now. Who is in class? Timothy. Timothy, are you in class? Thank you for joining. We want to continue with our discussion on chemistry. Nataka kujua who are in class today. What's it? If you're in class, talk to me. Yes, tunataka kupika lesson vibaya. So I can proceed, Sawa. So thank you for joining me. I would like to start our lesson, and what we are discussing today is alkaline earth metals. Alkaline earth metals. Basically, they are group 2 metals, group 2 elements. When writing the name of the group, you use Roman numbers. That is what we are always telling you to check on. Now, I want for you to know the members of alkaline earth metals. It is the one that ends with 2, 2, 2, then 2, 8, 2. Then these ones are members of group 2. Yeah, so you can name it. Inigani. Which metal or which element has electronic arrangement of 282? 2882. Which one has 282? Which one has 22? And which one has 2? All of these are group 2 elements. Yesterday we were discussing about group 1. If you missed yesterday's class, check the lesson that we did at 7 in the evening. Yesterday we did 2 lessons, but I would say you check the one that we discussed 7 in the evening. So for now, I would like us to check on alkaline earth metals. It's not something heavy. Yeah, I will just tell you what is expected of you. What are some of the questions that you can be asked as far as alkaline earth metals is concerned? First of all, we start with the members. Na members nimekupea ndio hizi. This one, but not a member of alkaline earth metals. So these three are now members of alkaline earth metals. 2, 2, it means it has atomic number of 4. So it is beryllium. 282, it has atomic number of 12. So it is magnesium. 2882, it has atomic number of 20. When you add these ones, itakupeleka mpaka 20. And so it is calcium. Are you together? These are the members. So what can we ask you about this? The first question is trends. The first question is state and explain the trends in atomic radius down the group. I will place that question up. I will be placing questions kwa chat section so that kazi yenu ni kusoma swali na muone fenye itakuwa how it needs to be answered. Yes. So state and explain the trends in atomic and ionic radius down the group. That is the first question. I will be mentioning the question, explaining it very well. So the first question, how can we answer it? Down the group, this is down the group. How can we answer it? Let me explain it. The size of the atom increases down the group. The size of the ions in group 2 also increases down the group. Explanation is 1. Because of increase in the number of occupied energy levels. From 2, 2, those are 2 energy levels. 282, those are 3 energy levels. 288, 2, those are 4 energy levels. You know, the size is determined by how far is the outermost energy level from the center of the nucleus. So if it has more energy levels, then it means it has a larger size. Are you together? Yes. Number 2. Ionic size is, you know, when you are going down the group. For example, if this 2, 2, this is the atomic size. Like in 2, in a manner, it may lose E2. So we have 2, 8, 2. Like in each ion is going to be 2, 8. We have 2, 8, 8, 2. So each ion is going to be 2, 8, 8. Now, down the group still, you can see there is an increase in the number of occupied energy levels. Likewise to this. That's why the atomic size and the ionic size increases down the group. Somebody to make a comment, because I have to listen to you so that nijue tuko pamoja. If you can hear me, please drop a comment. Just say we can hear you. Let me proceed. Sitaki maneno mingi. Sitaki hata tusumbuane sana. I just want you to say I'm audible. Yes. Now, we are moving on. We are moving on very well. So the other question is physical properties of these metals. Now, physical properties, to answer a melting point, they are very high melting points compared to the preceding alkali metals. Basically, alkaline earth metals have high melting points than alkali metals. I will explain to you. Okay, let me explain it. For example, which element is this? This is sodium. Which element is this? 282. This is magnesium. All of them have 3 energy levels. Yes, all of them have 3 energy levels. But magnesium has a higher melting point. Magnesium has a smaller size than sodium. What is the answer in a melting point? Why is magnesium having a higher melting point than sodium? There is what we call, by the way, if you ask a question, I was telling my students, anytime you ask a question that is talking about the issue of melting point, that question is asked based on the bond or structure You are supposed to explain why something is, you are supposed to ask based on the bond and structure. Now, in this case, magnesium has a higher metallic bond than sodium. It has a higher metallic bond than sodium. Why? It contributes 2 electrons to the sea or the cloud of electrons. Yes. So basically again, group 2, which is alkaline earth metals, are less reactive compared to group 1. Why? If you compare now this between sodium and magnesium, which one is the most reactive? It is sodium. Why? It is easier for sodium to lose 1 electron than for magnesium to lose 2 electrons. What is there here is the energy required to lose this 1 electron, we call it ionization energy, is less for sodium than for magnesium. So if it requires less energy to lose 1 electron, and that is the electron that needs to be lost for reaction to take place, then sodium reacts faster than magnesium. You use ionization energy, or you say it is easier to lose 1 than to lose 2. Are we moving on very well? Yeah. So that's the point. Let's proceed again. The other question I want to ask you is this. What is observed when alkaline earth metals are cut with a knife? The first observation is it is hard to cut. It is hard to cut. And even if it cuts, it is hard to cut. So it cannot easily be cut with a knife. Why? It is ductile. It is ductile. Ductile means it cannot be easily cut with a knife. Now, can you give us the observation made? I'm posting a question on our chat screen. I'm posting a question. I'm saying this. I'm asking a question. Beverly, thank you. I'm asking a question which I'm saying magnesium and calcium are separately used to complete an electric circuit. So that's not a question, that's a statement. Now the question is this. Explain the observations made. Explain the observations made. Magnesium and calcium are separately used to complete an electric circuit. Explain the observations made. What do you say? Let me give you the observations. It is observed that the 2 of them allows current to flow through them. Why? They have delocalized electrons. Because they have delocalized electrons. Yes. Because they have delocalized electrons. Yes. Another question is, discuss ionization energy down the group. In short, I'm asking, how does ionization energy vary down the group? What will you say? Group. The answer is this. As you move down the group, the ionization energy decreases. As you move down the group, the ionization energy decreases. Reason is this, because as you move down the group, there is increase in number of energy levels, whereby the outermost energy levels, the outermost electrons are loosely held. Are you together? They are loosely held. So it can easily be lost. Are we together, Beverly? Another question. What is observed when magnesium and calcium are heated in air? Let me post that question there. What is observed when magnesium and calcium are heated in air? What is observed when calcium and magnesium are heated in air? I will explain that. When magnesium is heated in air, it produces a flame, we call it the blinding flame. A flame that you cannot see it with your eyes because it can destroy your eyes. Yeah, that is for magnesium. Then it forms a white solid. By the way, I'm asking a question. Give me a comment there. When magnesium is burned in air, name 2 products formed. And remember, the 2 products are also white. Magnesium, when it is burned in air, there are 2 products which are white in color. There are 2 products which are white in color. What are the 2 products, Beverly? What are the 2 products formed when magnesium burns in air? Someone to remind me before the lesson ends, in case kama mtajibu, someone to remind me to mention the 2 products formed when magnesium burns in air. So my question is this: what happens when magnesium and calcium are heated in air? So tumesema magnesium burns with a blinding, brilliant white flame to form 2 products which I'm not telling you. I'm waiting for you to tell me in the or at the comment section. Calcium, on the other hand, will produce a faint orange flame. Faint orange flame. Faint orange flame. Good. Sawa. Now, products again formed when calcium burns in air. Forms white products. Is there anyone answering me? Okay, Beverly is saying that magnesium oxide and magnesium nitrite. Magnesium oxide and magnesium nitrite. Thank you. That is exactly what I wanted. Magnesium oxide, why? Because magnesium reacts with oxygen in air. Magnesium nitrite, why? Because magnesium reacts with the nitrogen in air. The same applies to calcium oxide and calcium nitrite. Now, I have another question. I'm just asking, Sonne, and if you know it, please place it there. The products of burnt magnesium, the ones in Beverly amesema polo, those products which are produced after burning it in air. And after adding water, we tested using a litmus paper, both red and blue. What are the observations? Yani, I'm saying this, tumechukua litmus paper. Sorry, tumechukua magnesium oxide. Tukachukua magnesium nitrite. Tukaweka kwa maji na tukaikoroga. Then tukachukua red litmus paper, dip ndani. Tukachukua blue litmus paper, dip ndani. What are the products formed? Oh, sorry, what is the observation in that case? Nasemaje? Na wangojea munijibu hiyo. I'm waiting for you. Muniambie. In that case, as you are giving me that answer, between beryllium, magnesium, and calcium, which one is the most reactive? Kama ulielewa ya jana, hata hii pia ni kitu rahisi. Between beryllium, calcium, hapa kwanza kuna magnesium, then calcium, which one is the most reactive? Or what is the trend of reactivity down the group? Yes, that is the question I'm also asking. I'm posing that question to you. Timothy Munga anasema the litmus paper will turn red. I'm waiting for another answer. Nangoja ya Beverly na Ndinda, alafu sasa I make a comment on the same. Yes. Now, in the meantime, as I'm waiting for Beverly to give us the answer over there, let me explain this. As you move down the group, the rate of reaction increases. As you move down the group, the rate of reaction increases. It increases inaongezeka. Why? As you move down the group, the ease of losing the outermost electron also increases. Are you together? So calcium is more reactive than magnesium, and magnesium is more reactive than beryllium. That's what I wanted you to know. Yes. Now, what is the product formed? Another question. What is the product formed when magnesium, calcium, or beryllium is reacted to the steam? Yeah, you take magnesium, you react with the steam. What will be the product formed? And also give us the observations made. Because staki tukae nayo sana, I will explain. Would burn in steam to give us hydrogen gas and magnesium oxide, which is a white light. The same applies to all the other metals. Now, let me explain that question before nimalizie. Hiyo ya nimeulizia, when you burn magnesium in air, itakupatia magnesium oxide. Sawa? Na ikupatia nini? Magnesium nitride. When you add water, magnesium oxide will give us magnesium hydroxide, which is a base. When you add water to magnesium nitride, it will still give you ammonia, magnesium hydroxide, all of them are bases. Sawa? So, when you put a red litmus paper, it will turn blue. When you put a blue, it will remain blue. I hope Timothy kidogo tumeelewana hapo. Timothy, tell me tumeelewana. Yeah. So, that is how it is. Now, another question which I would like to ask. We all know how to write equations. Magnesium and steam, make sure you can write a very good equation. Well balanced, just say it gives us magnesium oxide and hydrogen gas. Sawa? Yes. There's a diagram that for now I cannot display it to you, but I will just ask some questions later on that deals with that one. Now, there's a question here. State and explain what is observed. Let me paste for you the question on the comment section so that tutaiangalia sisi wote. The question reads, state and explain what is observed when magnesium ribbon reacts with dilute hydrochloric acid and sulfuric acids. What will you say in that question? So magnesium is reacting with two different acids, HCl and H2SO4. What will you say on the same? What will be your observations? State and explain what will be observed. First of all, in all the cases, a colorless gas that burns with a pop sound is produced. And the gas is hydrogen gas. That's the first one. Then a colorless solution is formed. The colorless solution is magnesium chloride when it was reacting with HCl and magnesium sulfate when it was reacting with sulfuric acid. Are you together? Yes, another question. This one is a question which is so much asked frequently. It's about calcium. Look at that question. State and explain what is observed when calcium reacts with dilute hydrochloric acid and sulfuric 6 acids. Calcium ikireact na HCl na calcium ireact na sulfuric 6 acid. There is a very significant difference which I would like us to talk about. State and explain what's observed when calcium reacts with dilute hydrochloric acid and sulfuric 6 acid. Now, there is, in all the cases, there is production of hydrogen gas, but a large amount of hydrogen gas is reacting with HCl than when it is reacting with sulfuric 6 acid. The reason is this. When calcium reacts with sulfuric 6 acid, it forms calcium sulfate, which is insoluble and prevents further reaction. When calcium reacts with sulfuric 6 acid, it forms insoluble calcium sulfate that prevents further reaction. Hapo tuko pamoja? Yes. But when it reacts with hydrochloric acid, it forms calcium chloride, which is soluble and does not prevent further reaction. Aya, taka tuende hii. Use of alkaline earth metals and their compounds. So to tenda very fast, ndakuwa tu napeana one use and you will see it being displayed. So the first use is magnesium is used in the manufacture of magnesium hydroxide. That is the first use. I hope we can see it over there. Magnesium is used in the manufacture of magnesium hydroxide, which is used as an antacid medicine. Yes, because it is non-toxic. That is the first use of alkaline earth metals. The second use, we use like 2 minutes giving uses. Another use of magnesium and aluminium. Another use is there. Make you can display. So it nimepeana 2 uses there. Magnesium is used in the manufacture of magnesium hydroxide. A low density alloy of magnesium and aluminium is used in aeroplane construction. Yes, and nipeane the use number 3. I hope we are following. Use number 3, and please be reading. Ndakuwa na paste hapo. Kazi yako ni kuandika haraka haraka. Hydrated calcium sulfate, which is called plaster of Paris, is used in hospitals to set fractured bones. That is use number 1, 2, 3. I'm going to use number 4 now. Use number 4, now or number 5, whatever the case. Cement is made by heating a mixture of calcium carbonate, which is limestone, clay and sand. It will give cement. That is a use. Another one. Mpaka nipeane sote, there are not so many. There are only 10 or 11. Calcium carbonate is used in extraction of iron. Tukisoma metals form 4, mutajua how it operates that way. How it operates or how it will operate. Those are the uses. Sijamalizia ingine. Tuko use number 6 ama we are now use number 6, which says calcium oxide, which is called a lime, is used to raise the soil pH. I will paste that one so for the sake of those who are writing. Na kama uandiki wewe soma tu. Lakini nashangaa mbona usiandike. Another one, calcium nitrate is used as a nitrogenous fertilizer. Calcium nitrate is used as a nitrogenous fertilizer. I'm pasting it there. Nitrogenous fertilizer. Magnesium oxide is used in the lining of furnaces. I hope we are all writing. Magnesium oxide is used in the lining of furnaces. Another use, we are almost there. I know Mechoka. Kuona very many uses. Barium sulfate is used in the diagnosis of ulcers. Second last, barium nitrate is used to produce the green flame in fireworks. Usiku nilisikia fireworks zikilipuliwa sijui upande gani huku. Sijui kama ulisikia fireworks huko kwenu. Ya mwisho, calcium carbonate is mixed with oil to make putty. Ama putty. Good. Those are the uses. Mshaandika Beverly. Nice. Now, nataka tujibu maswali kidogo for the next 20 minutes. I hope you are ready. Are you ready for the questions? Wale mko on, are you ready to answer the following questions? The questions. Wacha niwawekee swali kwa upao as you are telling me whether you are ready to answer these questions. Kuna swali hapa kazuri sana. I'm giving a table here. Nataka nikupee table uniambie ni metals ama ni non-metals. So we have W, X, Y and Z. Imekaa hivi. Nani? Mwambie nikueleze. So we have the element here. Umesemaje? Atomic radius, then we have ionic radius. Ende mwambie after 10 minutes nitakuwa nimemaliza. Yes, so we have this one. Look at this. W has 0.0. It is nanometers, meaning very small. 0.114. Hii ingine 0.195. Meaning this one is larger than this. The ionic radius is larger than this. Kwa hii W. Twende kwa X. X is 0.072. Na hii alafu the ionic radius is 0.136. 0.136. If you compare the two, this and this is still larger than this. For Y, it is 0.133. Then 0.216. For Z, it is 0.099. And then on that side, it's 0.181. Now, the question here is, that's the table. And we can see that in these four elements, the ionic radius are larger than the atomic radius. So the first question is this. Would this form part of metallic or non-metallic group? Explain. Hiyo ndaka mtu aniambie, hii W, X, Y and Z, is it for metals or non-metals? With us, Are these forming metals or non-metals? And the concept here is it has a larger ionic radius than the atomic radius. So ile kitu nataka ujiulize tu peke yako, kati ya metals na non-metals ni gani inakuanga na a larger ionic radius than the atomic radius? Are these metallic or non-metallic? I'm waiting for somebody. Most probably Beverly. Are these metals or non-metals? Stella Mwendwa anasema non-metals. Ni sawa. Mtu wa mwisho? I will explain in the next 1 minute kama ni metals ama non-metals. Okay, kama hakuna mwingine. Now look at this. Let's compare these two. Yesterday niliwapea nikawaambia between sodium ion, atom and sodium ion, kani ni kubwa, tukasema this is larger. I mean electrons, and in the process of losing electrons, it loses a whole energy level. Now, but for chlorine atom and chlorine ion, which one is larger? Chlorine ion. So whenever you see ionic radius larger than the atomic radius, it is for non-metals. Just like how Stella and Beverly have said, non-metals. So these are for non-metals because they have a larger ionic radius and atomic radius. Yes. Then suggest element that is the most reactive. Angalia tu itepo vizuri. Pick one element that is the most reactive. Tumeelewana ni non-metals. Now, let's pick element that is the most reactive. Ukitaka kujibu hii swali vizuri, can you go to halogens? Because tumejua ni non-metals. So, you have no business with metals now. Let's go to non-metals. Angalia pale kwa group ya halogens. How does the rate of reaction vary? The rate of reaction vary in this manner. As we move down the group, reactivity rate decreases. Meaning, ya kwanza pale juu, fluorine is the most reactive, followed by chlorine, followed by bromine, then iodine. In this case, the most reactive nonmetal is the one with the smallest atomic radius. Smallest atomic radius. Can you pick the one with the smallest atomic radius? Which one has the smallest atomic radius? That is it. Are you together, girls and boys? Yes, just pick the one with 0.09 ama 0.072. It is 0.072. Sawa sawa. Haya, another question. Unless kama uko na swali, uniambie, lakini kama hauna, we proceed. The question is here and you will see it on your screens. It is it's asking that question is, state the reason for using argon in electric light bulbs. State the reason for using argon in electric light bulbs. Stella, thank you. State the reason for using argon in electric light bulbs. What property is possessed by argon that makes it possible to be used in electric light bulbs? Reason is this. I was waiting for someone to type the answer. It is because of its inert nature. Argon is inert, so it provides inert environment for the bulb to work well. Sawa. That's the reason why we use argon in light bulbs. Sawa. Another question is this. Name two colored gases. Name two colored gases found in group 7. Name two colored gases found in group 7. We have very many colored gases, but I'm very specific on this. Name two colored gases found in group 7. The chemical name of group 7 is halogens. Name two colored gases found in group 7. Can we leave that comment very fast? The keyword is colored gases. What can you say, Stella? Let me explain that as I'm waiting for your comments over there. Two colored gases. First of all, remember bromine is colored, iodine is colored, fluorine is colored, chlorine is colored. Now, if you're not keen, kuna mwanafunzi alisikia tu colored na hajaikuwa keen aone, it should be gases. Akaweka bromine, it's supposed to be only two, fluorine and chlorine. Those are the only two colored gases. And the color they possess is yellow. The two of them are yellow. Right together? Yes, and let's come kuna mtu akona swali. Allow me to move to another question. Stella. Chlorine is correct, but bromine is not a gas. At room temperature, it is not. No, let me delete my comment. Kuna venye haijatokea venye nilikuwa nataka. So let me remove the last comment there. Yes. So we still have two more questions to go, and I hope you are ready for this. Na tulisema when you join class, you should stay up to the end. Sawa. Yes. So kuna swali hapa nataka ni peane alafu niwaeleze kitu ya muhimu sana. I was giving you a challenge the other day. That the challenge you need to give yourself is when you come to class, stay in class up to the end. You cannot compete with somebody mwenye anasoma 1 hour daily kwa kem. Na hiyo unakuja tu for 2 minutes unachungulia na unaenda. Sisi tukisoma malls, tukisoma kila kitu wewe tu unakuja kuchungulia nani yako kwa ile son na unaenda. Now, look at this. I'm throwing a table here. It has 2 columns. The column of the element, and it only has 3 elements, so ndaishia hapa P, Q, and R. P, Q, and R. Then this is the atomic size, radius. Then 0.19, P as 0.19 nanometers, nm. Very small. Hii ni kama kusema times 10 power negative 9 meters. Then equals 0.23 nanometers. Equal 0.15 nanometers. Ikiwa hivyo, yeah, we can see this is the smallest, followed by this, followed by this. Now, there is a question you have been asked. Which element has the highest ionization energy? Why? Between P, Q, and R, which element has the highest ionization energy? Which element has the highest ionization energy? Tuanzie hapo. First of all, if they start by questioning about ionization energy, you will know these are metals. PQR. Which one has the highest ionization energy? Affinity. I will take you from what you know to what you don't know. Some of you are typing. Look here. Ndaka tu twende pole pole. Hapa tuko na sodium na hapa tuko na potassium. Sawa? Between sodium and potassium, which one is the most reactive? Na tulisema ukiingia class unakaa mpaka mwisho. Which one is the most reactive? It is potassium. Sawa sawa. Between sodium and reactive. Haya, listen again here. Between potassium and sodium, which one has a larger atomic radius? It is potassium. Are you together? So potassium is having a larger atomic radius. It is the most reactive. Now, because it is the most reactive, between the two, tumeelewana potassium is the most reactive than sodium. Which one has a higher ionization energy? Kumbuka, ionization energy is the energy required to remove the outermost energy level. And for elements to react, they must lose, that is metals, they must lose the outermost energy level. If it requires a lot of energy for it to lose the outermost energy level, then it is the least reactive. If it requires smaller amount of energy, to lose the outermost electron, it is the most reactive. So this one, potassium, has the least amount of ionization energy. It has the least amount of ionization energy. Potassium. And it is the largest. So twende pale. The one that is the largest amongst the three should be the one having the highest amount of ionization energy. In that case, it should be Q. Hiyo kitu explanation kumeelewa? Good. Now, allow me to explain this. There are two terms watu kidogo wanakoseanga. Kuna term inaitwa ionization energy. Na kuna term inaitwa electron affinity. Electron affinity. Aya, nikimaliza hizi mbili, then our lesson will be done. But it will take me like few minutes from now. So, before you go and take your 4 o'clock tea, let's learn this kidogo. Good. Look here. Which combination of elements do you love that forms a compound? I will use the one that 99% of you used over lunchtime, and that is the salt. But I will say common. You know, nikisema salt is anything as long as kuna metal na kuna non-metal na imekutana, that's a salt. Now, common salt ni sodium, then ion formed together with chlorine ion. When the two forms, it forms a compound called sodium chloride. Aya. Ndaka tuandike electronic configuration of sodium and for chlorine. Sodium is 2 is to 8 is to 1. Chlorine is 2 is to 8 is to 7. Nilisema hivi, unaangalianga chlorine can either lose 7 or gain 1, but the easiest is gaining 1. Sodium can either gain 7 or lose 1, but the easiest is gaining losing 1. Now, this one will lose 1. This one we will gain 1. So sodium has to lose 1 and chlorine has to gain 1. Where is chlorine gaining from? The 1 lost by sodium. So sodium has to lose. And for it to lose, there must be some force that is taking away that particular electron. And that force is the energy known as ionization energy. Affinity is attraction to something. Ukisikia mtu akisema niko na affinity for, amesema I love that particular thing. Chlorine has what you call electron affinity. That is, electrons get attracted to chlorine. So electron affinity is mostly used to refer to non-metals. Ionization energy is mostly used to refer to metals or those that can gain, those that can lose electrons. Energy required to gain electrons, we call it electron affinity. Like the ones to lose, that is ionization energy. Up to that point, umeshika kitu nimeeleza? Are we together? Yes, I hope umeshika. I have last statement before we end our lesson. I have last statement, and the last, go and learn about. We all know what is ionization energy. Kitu tu nataka kuacha challenge nayo ni go and learn what is first ionization energy, what is second ionization energy, as you are moving on. Then from there you will understand. So I'm saying this, electron affinity is used to refer to nonmetals. Ionization energy is used to refer to metals. I hope we are together in that case. Haya. Yesterday mliona tulisumbuliwa na we had some technical errors night. But at night most of you were already asleep between 7 and 8. So let's be meeting 3 p.m. and if possible 7 p.m. We are still trying to find time to fix physics. Hebu mniambie mnataka to fix physics saa ngapi? Because chemistry itakaa 3 p.m. So physics tuweke saa ngapi? Unajua sijafunza physics for long na physics itabidi nianze kufunza next week, lakini I want to work with your time. Tuweke physics saa ngapi? Chemistry it will remain 3 p.m. every day including Christmas. But hii weekend tu sitakuwa, lakini the other days chemistry iko 3 p.m. I am waiting for you. Nipate time ya physics over the day. Hata mkitaka 10 p.m. tutaweka tu. Si nyinyi ndio mtakuwa awake. Mnasemaje? So as I'm waiting to get your replies, go and learn many of our other videos which are on our YouTube channel, Ambassador Speaks and Media. So what is there is also, if you are in need of exams, please contact us. We will send to wherever you are. You do it after umemaliza utulete tukumakie, or you give it to any teacher around you to mark for you. Now that no one is giving us time ya kufanya lesson ya physics, I will find any time that is okay with me. I fix it, then you will join me. So if you want those exams, tumepeana namba yetu hapo 0796 26 24 71. We will send it to you. We will parcel it to wherever you are. Ama 0740 for our office 6190 25. So if no one has a questions, thank you for joining us. We are out in 4, 3, 2,